Welcome to IB.
I'm back. So for today, we're going to talk about sequences and series. So these are the objectives for today. But before we move on to the lesson, let's have first an activity. So here I have two sets of numbers. The first one are 3, 6, 9, 12, 15, and the second one is 3, 6, 9 plus 12 plus 15. So observe, compare, and reflect on the patterns being shown. Okay, now, what is the difference between A and B? As you can see, for the first set of numbers, it is a list of numbers. What about the second one? Since there is a symbol of addition, we can say that it is a sum. A sum. Alright, so these are the key terms and definitions that we need to ponder in this lesson. So the first one is the series. So when we say series, it is the sum of the terms of a sequence. So for example, we have here 1, 3, 5. So the sequence is, let's say, 1, 3, 5. That is the sequence. And for the series, 1 plus 3 plus 5 is equal to 9. That will be your series. So when you say series, it is the sum of the terms of a sequence. The second term, which is the finite series, it is a series with a definite number of terms. When we say definite, you can count the terms. Or there is a limitation, there is an end. So let's have an example. Let's say we have 2 plus 4 plus 6 plus 8. That is a finite series. Why? Because we know that it has 4 terms. Only 4 terms. Now, let's have the third term, which is the infinite series. So this series, it continues without an end. For the finite series, there is an end. For infinite, without an end. So for example, let's say 1 plus 1/2 plus 1/4 plus 1/8 plus the ellipsis. So meaning it continues. With that in mind, we have the nth term, which is denoted by a and then subscript of n. Alright, now let's move on. What about the partial sum? It is the sum of the first n terms of a sequence. Let's proceed with an example. Alright. If the nth term of the sequence is a subscript n, then the partial sum is equal to the first term, the second term, third term, so on and so forth, plus the nth term. So for example, let's proceed with an example. We have a given of 1, 3, 5, 7, 9, and so on and so forth. So let's say that we are going to look for the fourth term. So your n will be 4. So let's say S4 is equal to 1 plus 3 plus 5 plus 7, and the answer is 16. So do not forget that the S subscript n is the nth term of the series. Alright, so let's have the last term, which is the sigma notation. It is a shorthand symbol used to express a series. Okay, to write, let's say, we will write first term, second term, third term, so on and so forth, plus nth term in sigma notation. So it will be like this. N is equal to 1, and then this is the end and the expression. So in general, N will be the start, and this will be your N. Let's denote it as K, and this will become the expression in terms of of the nth term. So let's proceed with an example. For example, we have 1, 2, 3, 4, 5. That is the sequence. So if we are going to put it into sigma notation, let's say 1 plus 2 plus 3 plus 4 plus 5, this will become, so the n will be, or the start is 1. And how many terms do we have? The n will be 5. And when it comes to the expression in terms of the nth term, it will be a subscript n. That's it. That is the sigma notation. Now let's move on. For you to understand more the sigma or the series, let's have an activity. Number 1. Find the sum of the first four terms of the sequence. So what are we going to do? Just keep on adding the 4 terms. So 3 plus 7 plus 11 plus 15. So the answer is 36. Very good. What about the number 2? Find the sum of the sequence. So again, when we say sum, we need to add them. 5 plus 10 plus 20 plus 40 plus 50. The answer is The answer will be 15 plus 20, 25. 5 plus 10, 15 plus 20, 35, 75. So we have 125. Now let's move on. For number 3, write the series 2 plus 4 plus 6 plus 8 plus 10 into a sigma notation. So for number 3, as you can see, we have 5 terms. 5 terms in the series. So the n is 1 because that is the starting point, and the n is 5 because we have 5 terms. But what about the expression? So as you can see here, we can say that it is, the pattern will be multiplied by 2. So times 2 times, 2 of n. So the 2n. So the pattern will be 2n. Why? 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5 multiplied by 5. Number 4. So evaluate the series written in sigma notation. So if n is equal to 1, 3, 1 plus 1, not forget that this is the expression being used based on the sigma notation. So the answer is 4. If n is 2, the answer is 7. If n is 3, the answer is 10. If n is 4, the answer is 13. I started with 1 because the sigma notation that I must start with 1. And it ends with n is equal to 4. Now the next thing is we need to add the result. So we have 4 plus 7 plus 10 plus 13. 4 plus 7 plus 10 plus 13. So the answer is 34. With that in mind, we can say that the answer will be 34 in sigma notation. Alright.